Today's video is going to be part one of rules of exponents. Specifically, we are going to talk about combining exponents. Rule one is the product rule. That is when you have some base to an exponent times that same base to some other exponent. And the way you get that, as most of you already know, is to add the exponents. So for example, if I had 2 to the 5th times 2 to the 4th, well, that would be 2 to the 5 plus 4, that's 2 to the 9th. But how did I know that? That's a really important thing. It's important that we not just take this formula for granted. Where did it come from? So we already know it's 2 to the 9th by this rule. So let's look at this another way so that you can see why 2 to the 9th is the correct answer. So this 2 to the 5th here, we could represent that as 2 times 2 times 2 times 2 times 2, right? 2 times itself 5 times. And then we could take this 2 to the 4th and rewrite that as 2 times 2 times 2 times 2. And of course, these two products are being multiplied together. So looking at this now, well, I see 1, 2, 3, 4, 5, 6, 7, 8, 9 2's all being multiplied together. So that seems like 2 to the 9th. So this isn't any sort of magic. It's really just looking at the definition of exponents and the definition of multiplication and kind of putting them together. I know that it can get very confusing that somehow multiplication is addition in some weird way. I get it. It'll take a little bit of practice, but it's really follows the same rules as any other algebra. So let's go ahead and do a couple more examples. Now, positive and negative numbers are giving a lot of you a hard time. You will want to brush up on your arithmetic skills because this number here, I've seen responses anywhere from 3 to the negative 12th, I've seen 3 to the 2, I've seen 3 to the negative 2, which happens to be the correct answer. But you have to be able to add and subtract these positive and negative numbers accurately. So be careful with that. 5 plus negative 7 is negative 2. And yes, we're going to do a whole different video on negative exponents, but we could call that 1 over 3 to the 2 as well if we want. Both answers are correct. Example 3. Let's do x to the negative 5 times x to the negative 7. Well, negative 5 plus negative 7, if I'm down at negative 5 and I continue down, negative 6, negative 7, negative 8, negative 9, I am at negative 12. And actually, here, I'll even show my work. The parentheses aren't necessary, I just use them because they make things a little bit more clear to me. And that's the product rule for exponents. I'm going to scooch to the side here. Rule 2, the quotient rule. I actually don't like this rule very much. It feels redundant to me, but it might help you. Once we know what negative exponents mean, we don't need a separate rule for quotients. But again, if it helps you, then I want to teach it. So the quotient rule goes like this. If I have some base to an exponent and it is divided by that same base to another exponent, well, it makes intuitive sense. If you multiply two things with the same base, you add the exponents. If you divide two numbers with the same base, it stands to reason that you would subtract the exponents. And that is exactly what you do. So again, As an example, if we have x to the 10th divided by x to the 4th, well, the answer would be x to the 10 minus 4. Don't be afraid to count on your fingers if you have to. So long as you know which direction you're going, don't worry about it. So 10, 9, 8, 7, 6. So x to the 6th power. Now again, like with rule 1, let's actually dip into why this is what it is, okay? So we're going to take this x to the 10th, and we're going to break it down, right? It is the same as x times x times x 10 times. And on the bottom of this fraction, we've got x to the 4th. Now again, now that we've spread these out to as far as they can go, we can start seeing why this subtraction happens. This x over x right here, that's just 1, right? I prefer to say that it's 1 rather than it cancels out, because if they all cancel out, there's still a 1 there, right? But this x over x is also 1. This x over x is also 1. This x over x is also 1. So now that we've sectioned off all of these 1's, what do we have left? X to the 1, 2, 3, 4, 5, 6. So that's why the quotient rule works. Now we're going to do a few examples on the quotient rule because it is particularly difficult to subtract negative numbers because there's all sorts of opposite weirdness going on. So let's say we've got 3 to the 5th divided by 3 to the 8th. We'll start easy and we'll ramp up. Well, that's going to be 3 to the 5 minus 8. 5 minus 8. Well, if I'm starting at 5 and I'm going down 8, it takes me 5 to get to 0, and then I have another 3 to go. So this should be 3 to the negative 3rd power. Example 3. Let's do 10 to the 10th divided by 10 to the negative 3rd. Well, that's 10, and we got to be careful here, to the 10 minus negative 3. And this is where a lot of people get tripped up. Right there. That minus negative, which looks kind of like an emoji now that I'm looking at it, means that it turns positive, right? When you subtract a negative, you are actually moving up the number line. So that's 10, 11, 12, 13. This is 10 to the 13th power. That's particularly useful, by the way, when you're looking at scientific notation. In fact, let's talk about that. Example 4. If I had something like 8 times 10 to the 3rd power divided by 4 times 10 to the negative 5th power, well, the normal numbers, they act just the way you know normal numbers act. 8 divided by 4 is 2. That still works the same ordinary normal way, right? Division is still division. Don't forget what you learned in elementary school. But to get that side, well, that's going to be 10 to the, again, be careful, 3 minus negative 5. So I'm starting at 3 and I'm going up 5, which means 2 times 10 to the 8th power. I'm going to do one more. Let's say y to the negative 4th divided by y to the 3rd. Okay. Well, that's going to give us y to the negative 4 minus 3. If I'm starting at negative 4 and I go down another 3, that's negative 5, negative 6, negative 7. So y to the negative 7th power. By the way, some of you may have noticed that this y to the negative 4th, and again, we're going to talk about this in the video on negative exponents, but you could move it down here and make it y to the 4th. And if you did that, you would get 1 over y to the 7th, which is the same thing. So if you were beginning to notice those patterns, follow those instincts, because there are lots of different ways to manipulate these exponents, and a lot of them will be very useful to solving problems. Let's move on to the last rule, rule number 3. Not the last rule, but the last rule for today. And rule 3 is called the power of a power rule for exponents. And it goes something like this. If I have some number to some exponent, and then I raise that to some other exponent. You see how this is different from what we were doing over here, where we had two separate numbers being multiplied together. Instead, we have some number with an exponent being raised to another exponent. So when we do that, we take the two exponents and multiply them. And again, we'll see why in a moment, but let's do an example. If I have a to the 5th power to the 2nd power, well, that's going to equal a to the 5 times 2 equals a to the 10th. But like the other two, I'm not going to ask you to take my word for it. Let's take this a to the 5th squared and rewrite it. Well, that's a to the 5th times a to the 5th, right? That's what squared means. You take the thing and you multiply it by itself, a to the 5th times a to the 5th. Well, we've already got a rule for that. Oop, too far. We've already got a rule for that, right? If you have two things with the same base multiplying together, you add the exponents. So this becomes a to the 10th by the previous rule. Let's try another one. Let's say we've got 2 squared to the negative 3rd. Well, that would give us 2 to the 2 times negative 3. Again, you don't have to use parentheses if you don't want to. I just prefer it because this negative here could be confusing otherwise, right? I don't want to think that it's 2 minus 3. I want to make sure that I remember that it's 2 times negative 3. But it's up to you. And that gives me 2 to the negative 6. Let's do another one. Let's say I've got... Let's do something crazy. Let's pretend that we can use fractions. We will be doing a video on fraction exponents in a little bit, but just to show you that it all works the same, let's use some fractions. Let's say I've got x to the 1/2, and I raise that to the 4th power. Now, I know a lot of you are fraction phobic, which is actually why I'm doing this. I want to remind you that multiplying fractions is not actually that bad. So I've got 1/2 times 4, right? But 4 isn't just a whole number, it's also a fraction. That's 4 over 1. And remember, when multiplying fractions, you simply multiply straight across the top and straight across the bottom. That's all there is to it. Straight across the top, straight across the bottom. So x to the 1 times 4 is 4, 2 times 1 is 2. You get x to the 4 over 2, which is x squared. And that's about all the time I have for this particular video. Just as a quick review, this video was primarily about the three combining exponents rules: the product rule, the quotient rule, and the power of a power rule. In the next video, we're going to be covering how to distribute exponents to multiple bases. For now, I hope that video helped you out. If it didn't, or if you have any questions, please do put those in the comments. I will respond to them, no problem. See you later.